Hello again. In this video we're going to look at limits again, and this time we're going to evaluate a limit using a numerical technique. So if you watched the last video, what we talked about, what we looked at, was evaluating a limit, or at least understanding the idea of a limit from a graphical approach. So real quickly, we have the line 2x plus 1 here. Here's the function. And if you recall, this represented my x coordinate, and this is representing my red ball, or the height that I'm trying to figure out where it's going towards if this gets close to a specific value. So let's choose 2. Let's let A get really close to 2. And as A gets really close to 2, our ball looks like it's getting really close to the height of 5. Okay? If I jump to the right-hand side, erase the traces, if I get to the right of 2, and let A approach 2 from the right-hand side, you could see that the ball is getting close to the height of 5 from up above. Okay, so in the last video, we went through this in a little bit more detail, so if you missed that, you can go watch that. But the idea here is that the limit from the left and from the right, as x approaches 2, in this example is 5. Okay, well, we're going to look at the same exact example, but we're going to do it with a little bit different approach. Okay, so here I have my calculator, and the calculator is in the y-editor window right here, and you can see that I've entered in 2x plus 1. These are other functions that I've entered in that I haven't turned on yet. I'll do those in a minute. Okay, so right now I have this function turned on. You can see the 3 windows over here. This is the table window. This is the graph of that function, and what I'm interested in is this table. So I'm going to bring up my table on my home screen, and I'm going to plug in values that get very, very close to 2. Remember, I don't care about what happens at 2. Maybe 2 exists, maybe it doesn't. It really doesn't matter. So I'm going to choose a number that's very close to 2 from the left-hand side. And 1.9 is pretty close, and I hit enter. And you see that I get a value of 4.8. Well, what if we can get a little closer? 1.99 is a little bit closer to 2 than 1.9 was. So I hit enter, and you can see that now my x coordinate is slightly closer to 2, and it looks like my y coordinate is getting closer to 5. Well, let's do one more to see if we ever get to 5. And you can see all we did was we just got closer to 5. We didn't actually reach it, but we got pretty darn close to it. Okay, so it looks like as we're coming in on 2 from the left-hand side, it looks like my y value is approaching the value of 5 from below. Okay, so now what we're going to do is we're going to jump to the right of 2. And 2.1, I think everybody would agree, is to the right of 2. I hit enter, and now look at this. Now we're above 5. Okay, so let's get a little bit closer to 2. And 2.01, whoops, sorry about that. Okay, there we go. 2.01 is slightly closer to 2 than 2.1 was, so we hit enter. And you can see that we're slightly closer to 5. Okay, but we're creeping in on 5 from up above, whereas up here we were creeping in on 5 from down below. Let's do one more, 2.001, and you can see that we're closer to 5 yet. Okay, so I'm willing to bet that the limit of this function as x approaches 2, both from the left and from the right, appear to be 5 based on my numbers right here. It's not a proof. It doesn't conclusively show that that's what the limit is, but pretty good evidence that our limit is going to be 5 here. Okay, let's look at a different example. Let's go ahead and look at the function x squared. Okay, here it is, and we'll just do this real quick. So graphically what we're looking at is as x approaches 2 from the right-hand side, we're looking where's my y value, and it looks like it's getting close to 4. And if we do this from the left-hand side, it looks like it's getting close to 4 as well. So now if I jump over to my calculator and I switch to my other function, x squared, okay, you'll notice that my graph was updated. You'll also notice that my table was updated as well. And since I'm approaching the same thing, there's no need to go into my table and redo all of that. I can see that this progression here shows me that I'm getting close to 2. And if you look at the y values, it looks like the y values are getting close to 4 from below. This string of values here is getting close to 2 from the right-hand side. And as these values get close to 2, these values are getting close to 4 from up above. Okay, so one more example. And we're going to look at this piecewise function this time. A little bit more complicated function. Okay, and again, you can see the graph was updated. And if we come to the graph here, you'll notice that this piecewise function has kind of a break at 1. So you can bet that the interesting part of this graph is at 1. It's no longer at 2. So I want to know what is the limit of this function as I approach 1 from the left. Okay, you can kind of maybe picture it right here. I don't have the ball set up in this example. And what's the limit of this function as x approaches 1 from the right? You can kind of imagine what your ball would be doing if we let x approach from the right. Okay, so let's go back to the calculator. And we need to go back into the table this time because all of these values we're approaching 2, and we want to approach 1. So let's get to the right of 1 and see where my y value is. And you can see that we're at 0.9. 0.9 is slightly closer to 1 from the left. And you can see that we got slightly closer to 1 from below. And we'll do one more. And you can see that as x gets close to 1 from the left, y is getting close to 1 from below. Okay, well, let's jump to the right of 1. To the right of 1 would be 1.1. And notice that these values are completely different now. Okay, before they were kind of close, but now they're completely different. We're way up at 1.9. Okay, so let's get closer to 1 from the right and see what happens. And you can see that we're getting nowhere near this 1 that this guy was getting close to. It looks like we're getting closer to 2. And one more for good measure. And sure enough, it appears that as we approach 1 from the right, that my y value is getting very close to 2. You can barely make it out here on the graph. But if we check back over here, sure enough, as we get close to 1 from the left-hand side, my y value is getting close to 1 from below. Oops. And as we get close to 1 from the right-hand side, my y value is getting close to 2 from below. Okay, so I hope that helps. That's a numerical look at how you might evaluate a derivative. Again, we haven't gotten too specific into it. We haven't talked about the limit at 1 here. We haven't talked about when limits exist, when they don't exist. We're just kind of getting a feel for how to look at them graphically, numerically, and we'll define them more specifically in later videos. I hope that helps. We'll see you in the next video.